Linear functions are essential in calculus because a lot of times we approximate nonlinear functions with a linear function, so you really need to understand the parts. The first thing that we just really pound on you in calculus is the slope. Suppose I have any 2 points, x1, y1, and I want to find the slope between these 2 points. Well, there are 3 different ways we can write this. You can write this as rise over run, delta y over delta x, which you will get very used to using, that notation. Or y2 minus y1 divided by x2 minus x1. The slope-intercept form of the line is very useful. Y is mx plus b, because we can read off the slope and the y-intercept. However, the most useful form of the equation is the point-slope form for what we're doing in calculus. And that is y minus y1 is mx minus x1. And a lot of times, this is the beauty, you can leave it this way in calculus, where you couldn't in algebra. And that was really okay. The intercept form and the general form are wonderful, beautiful forms that have their place, just not in calculus. I have never asked a student to put an equation in either of those forms. Now let's talk about parallel lines. 2 lines are parallel if they have the same slope. Okay, so you can see if I'm in point-intercept form or point-slope form, that this is easy to read off. Normal lines, however, and when I say normal in calculus, I mean perpendiculars, then the slopes are negative reciprocals. Now, you probably saw this as m1 is minus 1 over m2. Horizontal lines have a slope of 0, so y is equal to some b. If I put in a slope of 0 up here, this is horizontal. And these are key formulas in calculus. While vertical lines have no slope. The slope is undefined. So for these, we don't have a slope at all, and we write these as, I don't know if I can spell here. A vertical line is x equals a. All right. Now, let's look at this right here. Suppose I have a slope of -4, and it goes, my line goes through the point 1, 2. What would the line look like? Well, I have a point and a slope, so let's use the point-slope formula. Y minus y1 is mx minus x1. Now, you always have to write the formula first, always. So, y minus 2 is equal to, the slope is -4, x minus 1. Now, you're going to want to distribute this out a little bit. Y minus 2 is equal to -4x plus 4. So y is -4x plus 6. What if I have 2 points and I want the equation of a line through them? Well, the first thing you have to do is find the slope. The slope is y2 minus y1 divided by x2 minus x1. And it does not matter which one you pick as x1, y1, and x2, y2. So let me pick this as x2, y2, because I like symmetry here. Whoops. All right, so y2 is -1 minus 5 divided by -2 minus 4. So this is -6 divided by -6. Oh, that's convenient. That's 1. So it has a slope of 1. I can pick either point I want. It does not matter. So I'm going to pick the point 4, 5. So y minus 5 is equal to 1x minus 4. So y minus 5 is x minus 4, or y is equal to x plus 1. is the equation of my line. Now finally, what if I want an equation of a line through the point and parallel to the given line? Well, the first thing you have to do is put this in point-slope form. So I have negative 2y is 1 minus 4x. So y is minus 1/2 plus 2x. So the slope in this case is equal to 2. So the next thing I need to do is put it in point-slope form. Y minus y naught is m, x minus x naught. So y minus 7 is equal to 2 times x minus 4. All right, so y minus 7 is 2x minus 8. So y is 2x minus 8 plus 7 plus 1. We're done.